This video is a demonstration of LSSR XML, a knowledge-sharing platform equipped with automated XML conversion for digital publication of academic papers and AI-powered integrated search capabilities. Orbis Fabrica is building a smarter world with its own AI technology, offering a platform for document analysis and intelligent knowledge sharing. LSSR XML is an AI-powered platform that not only automates XML conversion for academic papers but also provides vector DB-based intelligent services, such as smart search, summarization, translation, related paper recommendations, and expert-level Q&A. Now, the LSSR XML demo begins. Here is the initial screen of the system. Access to the system is granted through registered user login. The logged-in username is shown in the upper right corner. We now access LSSR 0 XML to submit an XML conversion request. Labeled as Summary, this screen displays usage statistics, showing how actively the system has been used, along with related costs and completed task counts. This is the document upload pop-up. You can create a work group and add a description to clearly identify the purpose of this work request. Simply click Select Your File button to select the academic paper you want to upload. Locate the academic papers on your computer, select them, and click Open. You can choose multiple files at once. Here, to PDF format papers have been selected. When you click the Upload button at the bottom, you'll see a list of files for this work group, along with a simple breakdown of the estimated cost for XML conversion. Let's select a file from the list. You'll see detailed information about the file, such as its name, size, number of pages, the date and time it was uploaded, and the total cost for XML conversion. Click the Pay button at the bottom left to proceed with the payment for the work request. The payment has been completed successfully. Now, go back to the service screen, check that the blue Payment Complete button appears at the bottom left, and then click on the Check and Download menu. Through this screen, you can check the progress of your requested task. Once the system completes the work, the download button will become active, allowing you to retrieve the final result. Back on the user statistics screen, the dashboard, you can quickly review the details of your request. Under the File Upload submenu, the task screen includes a preview feature that allows you to check whether the uploaded paper is the correct one. Finally, by checking the progress of the task, we wrap up the demo of how to request a job from the user screen. Now, let's take a look at how the academic paper is actually converted into XML within the system. This is the main screen of the system module that converts submitted academic papers into XML. Clicking Enter takes you to a screen where you can review the submitted files. You can see the file group, customers' comments, details about the group, and a full list of files included. Let's click on one of the files in the list. You'll be able to see detailed information about the file, including its name, size, file extension, type, number of pages, unit cost, and total cost. Back on the File Group List screen, you can use the preview to check for any missing content, errors, or damages before the system begins the conversion process. Clicking on Data Build opens the screen for the document layout analysis and the generation of JSON and XML. We'll start by converting the document into JSON format to analyze its structure. By clicking the JSON generation button, it will start the automatic conversion of the document into a JSON file. 2 academic papers, totaling 17 pages, are now being converted into 2 separate JSON files. Although academic papers may appear to follow a standard format, in reality, they often vary in style and structure, depending on the author and the academic journal. To handle the wide variety of document structures, an AI-based algorithm is applied during the automatic conversion to JSON for precise and detailed structural parsing. The JSON file has been successfully generated. For the first, click on JSON Meta Information View to check whether the title of the academic paper, the abstract, and the keywords have been correctly extracted. We now move straight into the XML file generation process. In the process of XML generation, the system organizes the paper by tagging its metadata, main text, tables, graphs, images, and equations using JATS XML, the journal article tag suite, which is a widely adopted international standard in academic publishing. Here, the system creates links between the citations and the reference list, converting them into a structured format, which has been done manually in the past. Orbis Fabrica has automated the entire process, making it possible to dramatically reduce both time and cost compared to traditional manual work. XML generation has been completed. Now, just like in the JSON step, click on View XML Metadata to review the title, abstract, and keywords of the paper. Now comes the embedding process. It helps the AI quickly understand the content of the paper, making services like chatbot possible. Now, we move on to creating a face index, a key step in building the vector DB and enabling RAG-based AI capabilities. At this point, we'll go back to the initial requester's view and walk through how to review the completed output. Log in again, using the same requester ID and password. Click on LSSR XML to enter the system. Go to the Check and Download menu to view and download the completed results. You'll notice that the yellow Waiting for Download button has changed to green, meaning the file is now available as a zip file download. Let's take a look at the files that were requested for processing. You can check the results, file by file. You'll find the completed XML file, along with visual content, like tables, graphs, and formulas, all converted into JPEG image files. Let's start by taking a look inside the XML file. The entire content of the paper, including metadata, the main body, and references, has been converted into a structured markup format. Next is the first figure from the paper, which has been extracted and processed as an image file. Let's go back to the file list and open the second one. Just like the previous case, you can see the XML file along with images generated from the visual data extracted from it. As with the first file, the XML markup structure has been successfully generated. In the second file as well, the visual data has been processed into images and saved in sequential order. Now, let's download the final output after completing the review. By clicking the green download button, the XML conversion results will be downloaded as a zip file, packaged in a compressed format. You can now see that two zip file packages have been created, one for each of the two academic papers requested. Let's open one of the zip files. There's one XML file and a total of 11 images included in the package. Let's open the XML file using Python. Academic papers, when converted to XML, are organized into three major parts: the front, body, and back. In the front section, which holds the bibliographic details, the journal information is organized under the journal meta, such as the journal name and publication date, etc. While the article's metadata, including the author name, title, and abstract, is contained under the article meta. In the body section, which contains the main content of the paper, the text is tagged by paragraph from the introduction to the conclusion, while tables, graphs, figures, and equations are separately tagged using their respective XML tags. Finally, the back section contains tagging for references and citation-related information. Now, using the PMC article previewer provided by the NCBI, the National Center for Biotechnology Information, a division of the U.S. National Library of Medicine, to visually review the structure and rendering of the XML output, and to check whether all elements, including text, tables, graphs, figures, and equations, are correctly linked and displayed as intended. Now, we'll upload one of the XML file packages that we previously downloaded. For reference, this web service is widely used across the JATS XML production industry, including conversion service providers, academic publishers, and e-journal platforms, to pre-check tagging structures, image linking, and layout issues. The file has been successfully uploaded and is now ready for preview. Let's compare the XML output shown in the preview with the original PDF version. We'll cross-check the original PDF to ensure that key metadata, such as the journal name, authors, title, abstract, and publication date, has been properly structured in the XML. By clicking on the author's name, you can view other research and articles they have contributed to. Additional details such as author information, supplementary notes, and copyright statements are available in expandable dropdown. When viewing the main text, image-processed visual elements are properly displayed, and references are linked to their corresponding citation details. By clicking a reference link, you can access the web page where the cited paper was published, and review its content. At the end of each chapter header, there is a convenient go-to link that takes you directly to the corresponding section in the main text. We've now gone through the complete process from requesting an academic paper for XML conversion to checking the final results. Coming up in the next video, we'll take a look at how these results can be applied to AI-based services like intelligent search and automated translation. Thank you for watching the demo video.